Solve the following differential equation. So we have a second derivative of y with respect to x equals x times the derivative of y with respect to x quantity squared. Okay, and then we're given a couple of initial conditions, which is convenient. Okay, so this is a second order differential equation because we have a second derivative right there. But since there's no just x term by itself, or term here without a derivative of y to x, we can do a substitution and sort of treat this as a first order differential equation. You'll see what I mean. So I'm going to say that we have, let's say, u for convenience. U equals dy dx. Therefore, we can rewrite this as derivative with respect to x of dy dx. Okay, I didn't have to do the substitution for that, but you'll see where I'm going here. And then we still have the x dy dx. That's supposed to be a y quantity squared. So then we have a derivative with respect to x of u equals x times u squared. And then just to be kind of fancy here, I'm going to write this as u prime of x. Nope, not going to do that. I'm going to do this as du dx equals x times u squared. Okay, so now this is going to be our first order differential equation that we're going to solve. So I'm going to change colors. Ooh, purple and green. And I'm going to do separation of variables. So we have 1 over u squared du equals x dx. Rewriting this once, just for convenience, I'm going to do u to the negative 2, because that way it's obviously the power rule. So now, taking the derivative of this, u, negative 2 plus 1 is negative 1. Divide by negative 1 is just going to be negative, equals x squared over 2. So what I did was I just took the integral of both sides. Whoop, whoop, separation of variables. Okay, so now we have this. And we're like, all right, what do we do from here? So we're going to do, oh, gee willikers, forgot the plus c. There we go, plus c. So now we're going to use our initial conditions. So this says, this says we're going to use y prime of 0 equals 1. Well, y prime is just going to be u. So this is the same as saying that u of 0 equals 1. So what this means is that when I plug in 0 for x, we're going to get u equals 1. So rewrite this. This is going to be negative 1 over u. And I'm going to write this as u of x just to be a little bit extra clear. X squared over 2 plus c. And when we plug in 0 for x, this becomes 0, well, 0 squared. And then we know that the value of u is going to be 1. So we have a little arrow, negative 1. Negative 1 divided by 1 is just 1, equals 0 over 2, which would be 0, which equals c. So we can say that negative 1 over u equals x squared over 2 minus 1. So it's really plus negative 1, but we're just going to distribute that negative out there. Okay, so now we got to this point, but we want it to be, we kind of want the u to be up top and look a little prettier. So we're going to do something like x squared over 2 minus 2 over 2 equals x squared minus 2 over 2. Therefore, 1 over u. This is just algebra, but it's one of those things where sometimes it's the algebra that makes things tough in life. All right, so then flipping this up, we have u equals 2 over 2 minus x squared. That's an x. And we know that u equals dy dx. So from here, we're going to do another, just integrate both sides. So we have dy equals 2 over 2 minus x squared dx. Oh, change colors. Probably don't really need to change colors here, but I'm going to because I want to. So then this is going to give us y equals, this is of the form of a hyperbolic arctangent. So what we want is, if we have something of the form 1 over 1 minus x squared, and we take the integral of this, then this will be the hyperbolic with the h arc, -1, basically meaning inverse of x. Now, your first thoughts here might be, wow, how did you know that? It's like, well, I've done this a lot. And the second question is, well, should you know this? Probably not. If you're studying this for a test, then memorize it for the test. If you're just a normal person that's trying to know things for life, it's good to know that this exists. Well, if you're an engineering type person, know that this exists, and then whenever you see something like this, become suspicious, and then just look it up on Google. So, know that it exists, look up on Google. But we need to get it into this form, and we have that. So what I'm going to do here is, a lot of people will be like, oh, it's obvious, it's something, something, something. Well, I'm not that smart. So what I'm going to do is I'm going to do a U substitution here. I'm going to say W equals, nope, I'm going to do a little bit of algebra first. So I'm going to say this is the integral of 2 over 2 minus, and I want to get a 2 out front here, so I'll do 2x squared over 2. And then if I want to get this 2 into the square root here, I'm going to have to, over the square, I'm going to have to get this square root. You'll see. So 2 over 2 minus 2x over square root of 2 squared. Because when you distribute this square here down to the square root of 2, it becomes 2, cancels the 2, and that's the same as x squared. So I really haven't actually changed anything. I've just rewritten things a little bit. So then we'll take this out. So this will be 2 over 2 times 1. Is there supposed to be a 2 down there? Probably. I'm gonna stick with that. So 1 minus x over square root of 2 squared dx. These cancel. One more time, just for extra clarity. 1 minus x over, that's a terrible x. I don't know why I'm writing them so small. X over square root of 2 squared dx. Okay, so now this is closer to the form that I want of this, but I'm going to do a U substitution. I've already used U, so I'm going to make this a double U substitution. So I'm going to say x over square root of 2 w squared equals x squared over 2, which is that. And then we're also going to need a dw. So dw equals dx over square root of 2, solving for dx. dx equals square root of 2 dw. Okay, then we're putting this all together, and we get 1 over 1 minus, now this is x squared over 2, which is that, so it's going to be 1 minus w squared, and then this dx is going to be square root of 2 times dw, and so square root of, it's a terrible square root of 2. Square root of 2 integral 1 over 1 minus w squared dw equals square root of 2 times the hyperbolic, inverse hyperbolic tangent of w. But we know that w is x over square root of 2, so we have square root of 2 tangent hyperbolic inverse x over square root of 2, and then we'll do a plus c. I'll say c2 just so we don't get confused with the previous c. And this equals y? I think y. Let's check back here real quick. Yep, integral of dy will just be y. So this is 90% done, probably more. Now we just got to plug in our initial condition up here. Come over here. Up. And so if we plug in 0 for x, so we know that 2 equals square root of 2 hyperbolic tangent inverse of 0 over square root of 2, which is just 0, plus C2. And I don't know what that is, so I am going to use a calculator real quick. Arc hyperbolic tangent, or tangent hyperbolic inverse of 0 is just 0. So this becomes 0. So we know that C2 equals 0. Therefore, we can, it doesn't equal 0, equals 2. Hup. That part equals 0, C2 equals 2. Good catch. Good catch. All right, so now our final answer is going to be y equals square root of 2 arc hyperbolic tangent of x over square root of 2 plus 2. So kind of an involved problem, but I thought it was pretty interesting because we are solving a second order differential equation, but we're basically using a technique that's similar to first order differential equations. So hope that helped. See you next time.